Hello, in this video let's discuss the question. Here is the question, read it and give it a try. A team is doing an analysis of dual cache performance. There are n requests in the queue to be processed by a service where payload size of ith request is payload size of I. There are two caches A and B in the service. If ith request is cached by cache A, then it is 1, else it is 0. And similarly for B, find the minimum sum of payload sizes of subset of requests in which each cache can serve at least min threshold requests or return -1 if they cannot. So for example, here is the payload size and here is the first vector. Let's assume it as v1 and it is v2. So for example, at an index, if v1 of I is 0 and v2 of v1 of index is 1 and v2 of index is 0, it means that it is only cached by first, and if it is 0 1, it is only cached by second, and if it is 1 1, it is cached by both, and if it is 0 0, it is not cached by anything. So for example, this is the payload size and we want to select some subset of these such that the first one will have at least greater than or equal to 3 requests and second one also will have at least 3 requests. So if we try to observe and take some test cases, the least value so that both conditions will get satisfied is 10, 12, 4 and 5. So the minimum sum is this and it will be 31. So we have to return 31 because this is the least possible sum that is possible, so that both requests, so here it is 1 plus 1 plus 1, so it is 3 and here it is 3 as well. So both are caching at least 3. So 31 is the answer, and the constraints are k and n can go up to 105, where k is the minimum threshold value, so it is 3, and it is k and it can go up to 105. So the first idea we can think of is some kind of recursion. So function of index and f1s, where for example this is the payload vector, and for example function of index and first index represents the answer from this index, and the first one should serve at least f and the second one should serve at least s. So the answer will be function of 0 and k, because initially we have to get at least k both, and we are assuming from the index 1, index 0, so it will be function of 0 k, and we are at index I, and what are the possible transitions at this index? So function of index and f and s, it is minimum of take and don't take. So we can select this in the subset or we cannot select this subset. So if we don't select this, the answer will be function of index plus 1 f and s, because we are not taking this and we are just calling to the next index, and as f and s are not decreased, it will be f and s. And for example, let's one of the cases be f greater than equal to 1 and s greater than equal to 1 and v1 of index is equal to 1 and v2 of index is equal to 1. It means that we have to serve at least one from first and one from second, and the index we are at is 1 and 1, so it means that it will satisfy the condition. And if it is yes, then we can take the present value, so it will be v of index plus, because it is the payload size, plus function of index plus 1 and f minus 1 s minus 1, because we are selecting the present index, so it means that one condition is reduced for both, because the present one is caching for both because it is 1 and 1, and we want at least one from both as well, so it will be plus function of index plus 1 f minus 1 s minus 1. So similarly we can simulate all test cases and finally we can return the minimum of take and don't take. But even if we try to memorize it in the terms of dp, because the changing states are index f and s, because index is changing to index plus 1 and f and s will be changed to f minus 1 s minus 1 or f minus 1 s minus 1. So if we try to memorize it, it will be the new state, and the space complexity and time complexity will be nk square, because it is up to n and these both are up to k, but clearly it will not pass because constraints are up to 105 for both n and k. And the given question is asks that we have to return for both at least k. So let's assume that we have to serve x1 for first one and x2 for second one, so that we can deal with more wide range of question. Given us asks us only for both values same k and k, and let's find a solution for at least x1 request for cache 1 and x2 request for cache 2, so that we can find the answer. And we saw that recursion on dp will not work in this case. So now let's try to start with some greedy idea. So obviously we want the least sum, so let's start from the least cost. So let's sort the given payload size, and with some comparator we can sort with these values as well. So we can store vector of payload size and the pair, and we can sort those so we cannot miss the value. And after sorting, we want the least sum, so let's start from the 0th index, and we want both 1 because k is 1, so we want both 1, and we can select this because this is the least possible value, and here we can serve 1, the first one because it is 1. So 4 plus, and we can go to the next index, and even from here we can select this because it is serving the next one. So it will be 4 plus 5, and both conditions are reduced, so it will be 0 0, and there are no more requests to be cached, so loop can break in and the value will be 9. But the answer is 6 because we can select the last one because it is 6 1 and 1. Both conditions, the both caches will be served, and it will be least value because we found that 9 from the first one, but here it is 6. So with this we can satisfy the both conditions and it will be least value. So this will not work. We cannot take the least sum always. And from this we understood that taking one is beneficial than other because it can act as 2 in 1 because it can cache both first and second one. So now let's try to take the ones that have both v1 index 1 and v2 index 1 because it can act as 2 in 1. And now let's assume that this is the payload vector and this is the first and second. And now let's sort the values with 1 1, and here it is only the 1 with 1 1, so we can take this. And for this even k is equal to 1, so with this one we are able to satisfy the both conditions greater than equal to 1 and greater than equal to 1, so the value will be 3. But the answer is not 3 because we can select the first one and second one, we can cache the second one from this and the first one from this, so the least sum will be 2 and it is not 3. So even this is not working as well. So what if we try to balance this? Because before both are not passing because we want to balance both. We want the least one and also we want to try to prioritize one if it is less but not always. So, and now we understood that we have to process something based on 0 1 1 1 and so on. Sorry, because we saw that 1 1 is able to serve both, 0 1 is able to serve second one, and 1 0 able to serve first one, and 0 0 is serving nothing. So these three are useful and this is not useful because it is not useful for us in any way. So we can try to store 0 1 all the payload sizes with 0 1 in the first vector and 1 0 in some other vector and so on, because we can sort these as well. And for at a point of time, if we want to get some value with 1 0, we have to select the least one because we want to get the least one. So if we sort these, we can get what is the least possible cost with the given value. It is 0 1 or 1 0 or 1 1. So we can simply use the vectors for all these three, and these are three vectors. Let's assume that for 1 0 the vector is first, and for 0 1 it is second, and for 1 1 it is both. So now let's assume that these are the values VA VB are for 0 1 and these are for 1 0, this is for 1 1. And now for example we have processed many things in the given question, and let's assume that we are at this index and this index. This means that we have already considered this for previous cases. Only then we will not take this before because these are the least possible ones. So obviously we will take these after before this. So obviously if we are at this index, we are sure that we have taken these indexes. So for example, let's assume that fp is the first index we are at in the 1 0 vector. So all indices up to fp are considered, or fp is a 0 index because there are no before indices possible. So if the index that is pointing to the first is in first vector is fp, it means that 1 0 values are starting from this because we either selected all values before for the previous iterations or fp is 0 as well. So similarly in 1 0 and 1 and 1 1. So for example, if this is bp, we have 5 elements, and if bp is 2, it means that we have already selected 0 and 1 before, and we can consider only only once. So from now we assume that this is the only bp vector, and this is the least possible value that we can take if we are trying to take this vector. So hope you understand this. And size of second is sn, size of first is fn, and size of both is fn, and the first pointers are fp, sp, and bb. And now we want to track the count of first and second left because obviously we want to know what are the requests that are already cached by first and second, and what are the requests left that to be cached by first and second. So we want to track these both vectors, both values, and let this be f and s. Initially f is equal to k and is equal to k because they given that we want at least k for both. So initially f is equal to k and is equal to k. And let's discuss some conditions. So what is f equal to 0 means? It means that at least k requests are satisfied for first one. Only then it can be 0 because initially f is equal to k. Then if we are taking at least k requests, only then it can be 0. So if f is equal to 0, it means that condition with respect to first one is satisfied. And similarly for the s is equal to 0. And fp is equal to fn. So fn is this one, the size, and fp is the least pointer that we are able to take for present one. And fp is equal to fn. For example, if this is the first vector and this is fn minus 1 and this is fn. So fp is equal to fn, it means that it is pointing to last, next to the last element. It means that we already considered all elements, because else it will be any one of these. But fp is fn, so it means that we have considered all these before. And from this, at this point, we cannot take anything from this vector because it is empty, because we have considered all this in the before iterations. So fp is equal to fn, no more values are left such that it is 1 and it is 0. So it is useless from now because we have considered all before. And similarly for sn and similarly for bn. So, and now let's try to simulate one thing. For example, this is the given arrays. These are the given arrays. This is the payload size. This is the 1 0 vector, and this is 0 1, and this is 1 1. So, and now let's assume that both are 4. 0, initial answer is 0, and first one should cache at least 4, and the second one should also cache at least 4. So we have at least one from both. We have at least one from both. So what are the possible cases? So we can select 1 0 1 0 1, 1 0 and 0 1, because we want both, because we have 1 and 1. To satisfy the condition, we have to take one at least from both. So we have to select the least from 1 0 or and least one from 0 1. And if we are not likely to take this, we must take 1 1, because these are the only possible cases to select both 1 1. So 1 0 plus 1 1 plus 0 1 or 1 1. So what are the least possible cost if we are trying to take 1 0 and 1 1? 1 0 and 0 1, it will be fp plus sp. Values at fp plus values at p, because these are the least values at present time. So it is 2 plus 3, and for bp it is 2. So 2 plus 3 and 2. Obviously it is the least one. So now at this index we are taking 1 1. So fp is same, because we did not take the vector, the value from fp. We have taken from bp because it is least cost. And similarly for sp, and we have taken element from bp, so the pointer is increased. So it means that we have taken 2, and this 2 is no longer useful, and the new bp is this, from bp to bn. And the answer is 2, because we have taken this, and the first one should serve at least 3, the second one should serve at least 3, because one is served from these both, 1 1. And similarly now the same case, it is 2, it is 3, and it is 2. So obviously even now it is better to take this, and now even now it will be incremented, so it will be 2, it will be 3, it will be 7. The answer is 4 till now, and the values, the first one should serve at least 2 from the first and from second as well, because we have taken 1 1 from this and 1 1 from this. So it reduced to 2, so it will be 2 2. And now, even now we have one both. So 1 0 plus 1 0 1 or 1 1. So 1 0 plus 0 1 least cost is 2 plus 3, because these are fp and sp. And for 1 1, the least value is 7, because we have taken these both before, and the least value left from 1 1 is 7. So now it is beneficial to take 0 1 plus 1 0, because 2 plus 3 is less than 7. So now fp will be incremented, sp will be incremented, and bp will be same as before. Now the answer will be 5 plus 4, because it will be for before it is 4, and now we are taking 5. It will be 9, and we 2 2, and we have taken 1 1 again, so it will be 1 1. And similarly we can do the possible best case at now, based on 1 0 plus 1 0 1 or 1 1, and we can get the final value till both are 0. So now let's take another example. So, and similarly this is the other vector, 1 0 0 1 1 1. And finally after the same iteration, we can understand that bp vector is going to complete, because even in both cases 2 is less than 2 plus 3, and even now 2 is less than 2 plus 3. So obviously it's better to take these both as well. And at one point the b vector is completed, because there are no values to be considered. So they given that we have to serve at least k, because we can take more than k as well. So even now, if the third value is less than both, for example we want 1 from the first cache and we want 0 from the second cache, it means the second condition is already satisfied. And we have the fp value as 2, it has 3 sp, and the first value as 1. Even now we can select 1, even though we do not have 0, even if we do not have 1, because they said at least 1, the condition is satisfied already for 2. but we can take again this as well. So we can check based on the greedy which is less. So here is the code for the before one. If f is greater than equal to 1 and s is greater than equal to 1, if fp is equal to fn or sp is equal to sn, it means that first vector is completed or second vector completed. So we have only 1 0 plus 1 0 1 or 1 1. So if any of these conditions satisfies, it means that we cannot satisfy this, because to take this we must have at least from one from this and we must have at least one from this. But if any of these satisfies, it means that there are no possible values to take from this or this as well. So if this is not possible, we must take from this because it is not possible to take from this. So if BP is equal to Bn, it means that B vector is also completed, both vector. So we cannot find the answer because at least one from this is completed and this is also completed as well. But we have both one. So it is not possible to get the value. So make count is equal to 1 and break the loop, because we understood that we cannot make the answer. Else it means that we have some, for example, this is both and we have some BP. So we can take the present value. So answer is equal to both of BP plus plus. We have taken this and incrementing BP, and f minus minus s minus minus, because we have taken one on and it will cache both, so new will be reduced. And else condition is if these both are there, for example, fp is not equal to fn and sp not equal to sn. So now we have two cases, 1 0 plus 0 1 or 1 0 1, 1 0 plus 0 1 or 1 1. So now if both of bp is less than or equal to this, we have discussed in the simulation, so based on the sum of which is less we can go with that. So if this is greater, we can go with both. So we are incrementing both pointer and answer. Similarly, if this is less, we can go with this. And finally, f minus minus s minus minus. So from the given question, it is given that we want k from both. And as we have discussed always, let's try to solve some bigger perspective where we want x1 from the first and x2 from second. So if f is equal to 2 and s equal to 1 initially, then we can take this because 3 plus 3 is greater than 2, so we can take both, and fp sp and bp. So f is equal to 1, s equal to 0. Now even now we can take from both because we want greater than or equal to x1 from the first and x2 from second. So even now we can take this, so answer will be 4 here. So this is the condition. If s is equal to 0 and if f is greater than or equal to 1, it means that the condition with respect to s is satisfied, and now we have only caches to be served from first only. So if f is greater than or equal to 1 and s is equal to 0, it means that we can take from 1 0 or 1 1 as well, because it is useless to take 0 1 because the condition with respect to second is already satisfied. So the first one will be useful from 1 0 or 1 1 based on the less one. So if f is equal to fn, it means that there is no value from first because we have taken all values from first. So the only choice left is 1 1. So if bp is equal to bn, it means that second one is filled as well. So count is equal to 1 and break the loop. Else we can take from bp and we can decrement f. And if bp and if fp is not equal to fn, similarly we can make this. And now in this case we fp is not equal to fn and bp not equal to bn. It means that we can take, the choice are both, we can take from the fp or we can take from bp as well. So now we will try to take the least cost. So if both is greater than equal to first, we will take both and we will increment bp. Else we will take first and we will decrease f, obviously, because even if we take from 1 0 and 1 1, the s is satisfied already, so we can only deal with f, and from these both we can reduce f minus minus. So the code is exactly same. We are initially inputting the all values and we are adding two vectors first, second and both, and we are sorting all because at any point we want the least cost with respect to any condition 0 1 1 0 1 1. And similarly f is equal to k is equal to k for both, and fp all are 0 initially, and I am equating with sizes, and initially count is 0 because we are assuming that we can find the answer, and we are using infinite loop because the only conditions for breaking the loop are we are unable to make the condition satisfied or both are 0. F is equal to 0 is equal to 0. So we can use break inside the loop instead of using in the while. So this is the loop for f greater than equal to 1 and s greater than equal to 1. And this is for at least 1 greater than equal to 1. Similarly this. And this means that f is equal to 0 and s equal to 0. So we can break the loop because we found the answer. And finally if count is equal to 1, it means answer is minus 1, else answer is answer. So hope you understand this. If you have any doubts, comment below. See you in the next video.